Welcome back to the instructional series on hierarchy of energy theory, where we unify all physics under one big, beautiful model. I am your theory influencer, Scott Gordon. If you are joining us for the first time, please go back and start learning hierarchy of energy theory from lesson 1 to get the most out of this and future lessons. In this segment, we go over some basic concepts regarding the motion of energy within their respective energy tiers. We then advance hierarchy of energy theory's physical model to lay out the basic internal structure of second energy tier particles whose energy is expressed using E equals mc squared. Hierarchy of energy theory provides a physical model that is represented by the math we already use to understand the universe. If we are looking for an answer to a problem, all we need to do is look at hierarchy of energy's physical model to see where the answer may lie. If something is not possible to create physically, such as a fundamental magnetic monopole particle, then it cannot exist and does not represent reality. Now, before we start constructing second energy tier particles, which are the particles that don't move at the speed of light, let's look at the concept of motion with regards to the three energy tiers of hierarchy of energy theory. Starting with spacetime, the motion of spacetime is not something that's intuitive. In an address given by Einstein on May 5, 1920 at the University of Leiden entitled Ether and the Theory of Relativity, Einstein stated, "There is an ether. According to general theory of relativity, space without ether is unthinkable." He goes on to say that the idea of motion may not be applied to it. Einstein was absolutely right. Let's look at the way Einstein worded his statement when he said space without ether is unthinkable. It suggests that space-time contains an ether. But hierarchy of energy theory tells us that space-time is the ether. In addition, Einstein said the idea of motion may not be applied to it. If motion of spacetime cannot be applied to it, then what does motion of spacetime mean? Hierarchy of energy theory's model shows that any motion of spacetime has less to do with an actual movement and more to do with spacetime's energy density. The problem is that we currently have no reason to believe that spacetime is an energy medium, where its energy varies from region to region. While there are hints that this is the case, we cannot directly measure the energy of spacetime. The hints include a moving reference frame in spacetime resulting in a relative increase in the underlying spacetime energy density along the direction of motion. Another hint is that we see the effects of dark energy, which was revealed in our last lesson as representing a gradient in spacetime's energy. We can never directly expose spacetime's energy because of the law of conservation of energy. And we cannot determine a variation in spacetime's energy density. And that's because the physical constants of spacetime do not change with changes in spacetime's energy density. Our physical constants are relative constants, a new concept introduced into the field of physics by hierarchy of energy theory. We have previously shown that the motion of spacetime is expressed mathematically by the relative quantum distance and the relative quantum time unit, where both these parameters are raised to the zero power. The ratio of the quantum distance divided by the quantum time unit represents motion. And this ratio is always 1. But when it comes to space-time, this ratio does not represent an actual velocity. That's because the units of distance and the units of time are also raised to the zero power. And anything raised to the zero power is 1, and that includes the units of distance and time. A meter or a second raised to the zero power is 1. It's not 1 meter or 1 second, it's just 1. Therefore, no actual units of distance and no actual units of time are associated with this ratio that represents movement. So as Einstein said, the idea of motion may not be assigned to spacetime. And here's the kicker. In the equation for the energy of spacetime, it doesn't matter what the energy is in our underlying spacetime. It is always related to c to the zero power. E sub 0 equals m sub 0 times c to the zero power. Moving on to the next energy tier, A photon, or the first energy tier, must always move at c to the first power, or the speed of light. This means that no matter what the underlying energy of a photon's spacetime is, the photon will always be measured as moving through it at the speed of light. E equals Planck's constant divided by the wavelength, all multiplied by c to the first power. The speed of light is always measured at the same value, no matter what the underlying spacetime energy is, and this is represented in the concept of the relative constant. The concept of the relative constant cannot be overstressed, as it is an important concept introduced into our foundation of physics by hierarchy of energy theory. But what about particles that are not moving at the speed of light? How should we conceive of them? Peter Higgs came up with a mechanism where particles containing mass would interact with the Higgs field. The stronger the interaction with the Higgs field, the more difficult it is to get the particle moving through the Higgs field. The proposal of the Higgs field adds yet another energy field that exists throughout spacetime. And of course, according to physicists, any proposed field should have a particle representing a disturbance in it. On January 4th, 2012, the Higgs boson was found. It was considered a great accomplishment, taking many decades to reach. Finding the Higgs boson was considered confirmation of the science behind the Higgs mechanism. I have an interesting story about the Higgs. When I first developed hierarchy of energy theory, it showed that a Higgs field was not necessary for a particle to have the property of mass. And in this and future lessons, you will soon know why. Now, this is not to say that an energy field having the shape of a sombrero doesn't exist. It does. However, the sombrero-shaped field is created by the mass present in the particle, and not the field creating the mass. To me, it looks like Higgs got the cart before the horse. But I'll let you be the judge as we advance hierarchy of energy theory to that level in future lessons. Getting back to the particles that don't move at the speed of light, anything in spacetime that is not moving through spacetime at the speed of light can be considered not moving at all. That's because we can always put ourselves in the same reference frame as the particle, where all the laws of physics remain the same in that inertial reference frame. With this understanding, the time has finally come to begin our construction of the second tier energy particle. But how do we begin? Let's first recall that hierarchy of energy theory is the ultimate reductionist theory. That means we can only use what we already know to exist. So if we're going to create a particle of the second energy tier, the only ingredients that we can use would be space-time, which may be in a chaotic state as it is undergoing a vacuum decay phenomena, or what we know as the Big Bang. And we can also use the primordial photons, all leading with the compression portion of their internal wave structure. But if the energy that makes up particles must always move at the speed of light, how do we create a second energy tier particle existing in spacetime that doesn't move at the speed of light? And let's also keep in mind that after the particle is created, it cannot lose any of its energy into the spacetime energy medium. So, who wants to think of a way to maintain all these criteria as we create a second energy tier particle from the ingredients already existing in our universe? You can pause the video here and give this some thought. But for the rest of you, well, I'll tell you. A primordial photon is a longitudinal compression stretching shockwave in spacetime. Let's consider for now only the photon's directional diameter. How do we keep the photon's directional diameter moving at the speed of light while it's not moving through spacetime at the speed of light? We can do this by making a photon's directional diameter move in a circle. But is it possible to make a photon move in spacetime along a circular path? The only way for the photon to move in a circular path is to have the photon see the circular path as a straight path in spacetime. So how do we get a stable circular path of spacetime to exist? Great question. And hierarchy of energy theory gives us a great answer. The way to make a circular path look like a straight path to a photon is to get spacetime itself moving in a circular path at the speed of light. But how can we get spacetime to move in a circular path? The only thing we have to try to move spacetime is the primordial photons. If we try to use an entire photon, we would be moving the underlying spacetime forward and then backwards. This back and forth motion of spacetime could never provide the means to accelerate spacetime into a circular path. But what if we used only the forward half or only the trailing half of a photon? The leading half compresses and moves spacetime forward by one quantum distance, and the trailing half stretches spacetime and moves spacetime backwards by one quantum distance. By using the forward half or trailing half of a photon, the underlying spacetime can be accelerated to the speed of light. And let's also remember that once the particle is formed, there must not be any net displacement of spacetime. The only way to accomplish this is to have the displaced spacetime replace itself. And this is exactly what happens when spacetime moves in a circular path. The spacetime being displaced replaces itself as it moves in a circle. And with this simple construct, we satisfy the criteria previously set forth, where the photon still moves at the speed of light. The particle, represented by energy moving in a circular path, is not moving in spacetime, and spacetime has no net displacement once the particle is created. As we develop this model of the second energy tier particle, we will see how all the math that we have falls into place regarding its properties. This would include the interactions of these particles as they are described in the theories of general relativity and quantum mechanics, and even more advanced theories such as the Standard Model and quantum field theory. And yes, even shed some light on the Higgs mechanism. Now that we have a way to start spacetime moving in a circular motion, when will it create a perfect circular path? Well, that will occur when the underlying spacetime is accelerated to, yep, you guessed it, the speed of light. But why? Well, I'll tell you why. Once the underlying spacetime is moving circularly at the speed of light, it's analogous to when a building block was accelerated to the speed of light in creating a photon of the first energy tier. A quantum distance of energy is added into the circular path, whether it is by compressing the path or stretching the path. As we add energy to accelerate the half photon, that additional energy will be added into the underlying spacetime by accelerating the underlying spacetime either forward or backwards. As more and more energy is added into the system, the underlying spacetime moves faster and faster. The photon is still moving at the speed of light, but now on top of the accelerating spacetime. Once the underlying spacetime is accelerated to the speed of light, a few things happen. First, the additional energy used to accelerate the underlying spacetime to the speed of light results in the underlying spacetime jumping up to the first energy tier. Second, and simultaneously, the energy of the original half photon moving at c is now moving at c on spacetime that is also circularly moving at c. This represents the photon making the jump from the first energy tier to the second energy tier. When energy jumps to the next higher energy tier, the energy is locked into that energy tier. This locking mechanism is built into a particle's basic internal energy structure. The energy of a photon moving in spacetime is expressed using c to the first power. The energy of the second energy tier particle has its energy moving circularly at the speed of light on spacetime that is also moving circularly at the speed of light. The energy of the second energy particle is expressed using c to the second power. This is how the energy of our universe is organized within a hierarchy. A hierarchy based on the speed of light raised to the 0 power for spacetime, raised to the first power for light, and raised to the second power for particles containing mass. This is the basis for hierarchy of energy theory, which is expressed in this 1-inch long equation. I would like to make it very clear that when a second energy particle is created and energy jumps to the higher energy tiers, the energies are locked into a coherent particle where its energy will not dissipate into the spacetime energy medium. The fact that a particle's internal energy structure includes a mechanism of how its energy is locked into a cohesive unit is an important feature of hierarchy of energy theory. This feature is in direct contrast to quantum field theory's physical model, where particles are said to be disturbances in energy fields that permeate all spacetime. Not only does quantum field theory have no explanation of how a specific quantum disturbance comes to exist in its associated energy field, it gives no reason why the energy of this disturbance does not dissipate into the energy field it's associated with. On top of that, it has no explanation of how any of the various energy fields proposed in quantum field theory come to exist. In this lesson, we started to provide the rudimentary structure of the second energy tier particle. When we provided the rudimentary structure of a photon as a building block of spacetime accelerated to the speed of light moving in spacetime, we still had a lot to unravel until reaching the complete internal energy structure of the primordial photon. The same applies here. The idea of a half photon moving at c along a circular path on its underlying spacetime that is also moving at the speed of light on the same circular path is just the start. We have a lot to unravel, and it will require many lessons to get through what we need to cover. In closing this lesson, I'll leave the string theorist something to think about. As I previously compared the directional diameter of a photon being the open string in string theory, the half photon moving circularly in the second energy tier particle is in essence the closed string of a particle in string theory. And for you physicists waiting for the detailed math to be extracted from this model, please continue to be patient. It's coming. But we still have a few more lessons and things to discuss, such as how does our model of a second energy tier particle create an electric charge or magnetic fields? And how does it come to have the property of spin? How does it come to have mass? And how does the mass create a gravitational field? And why are fundamental magnetic monopole particles impossible to exist? Those are the topics of our next few videos. If you are curious about this novel approach to finding the theory of everything, then click the like button below and subscribe to this channel so you can be notified when future lessons are released.